Hi there and welcome. It's Matrix Uploaded. It's time for Physical Sciences. My name is Tinyiko Kosa and today we're going to talk about gravitational fields. And before we start talking much about the fields, I want to take you back and link a lesson we had about momentum and change in momentum. And I'm going to talk about impulse, which is actually change in momentum. Now, if we have a ball that is thrown against the wall. So this one here, this part here, it's a ball thrown against the wall. And as it goes towards the wall, it hits the wall there. And obviously it's going to bounce back. So this is just done for us to understand, just for conversion here. This ball hits the wall there and it's going to get it's going to rebound and go in that direction. Now, if we take the direction towards the wall as positive, the direction away from the wall is going to be negative. Now, definitely here there has been a change in momentum. Remember that momentum is mass times velocity, and it has got direction, so it's a vector quantity. Now, V to the right is positive here. Now, if V is observed as going to the left, it's going to be negative. So we've got negative momentum at the end. But then, now, this change in momentum, what caused the change in momentum? The thing that causes change in momentum is this agent here called force. Force causes momentum to change. Now, can we know how long this force acts? Because how long the force acts will actually tell us how much change in momentum has occurred on our object. In this case, on our ball here. This is the ball. Okay? Now, if we have the force and we get the product of the force and how long, so upon hitting this wall, how long was the ball and the wall in contact with each other? That time, if we have it, it is going to give us our change in momentum. And this quantity here that we're talking about, the F delta T, is known as impulse. So impulse equals F delta T equals change in momentum. Okay, and what is more important here is to note or understand that this change in momentum is caused by that force there. Okay, and from here you can also tell that this force is actually, or it can be given by the rate of change of momentum if you actually make F the subject of the formula there. That's also very important to understand. So we know that when we have a force acting on an object, that force is going to change the momentum of the object. The momentum of the object, obviously, because it's a vector quantity, it can be changed in terms of the magnitude. In other words, how big that momentum is, and maybe maintains its original direction. Or the change can actually happen because the force that acts on that object causes it to change its direction. So in that way, you have change in momentum, because any change in direction, any change in magnitude, when we talk in momentum, is actually change in momentum. So the change can be in the direction, and maybe the magnitude staying the same. But then, the other thing that can happen is that both the direction and the magnitude or the size of the momentum can actually change through the action of a force. Okay, so that's what we have there. And this force here, okay, this force here, when we begin to try and look at these forces here, for objects that are moving up and down, okay, so up and down motion, the force acting here, it's something else, which we will talk more in details in the next sections of this lesson. This force here is the gravitational force. And this gravitational force is the force that exists between two masses or two objects. And this force, of course, has got, like any other force, can cause an object to change its momentum. Okay, so this is quite important. So it's either that the force is between objects like that, or we can have it as a gravitational force, which is a force of the in an up and down motion. And of course, even here, gravitational force, which is between this object and that object. Okay, remember, between any two objects. Right, let's leave it there for now and see you in the next section.